Moving on to electric potential due to what? Is there any surface left for which we have to still find out the value of electric potential? There is the system of charge which is minus q and plus q, and you call it by name electric dipole. So we will be finding out the value of electric potential for electric dipole on, guys, what is the value of potential at the center of dipole? 2kq by a. Am I right? No, I was not. It is 0. Why? It is a scalar quantity. Instead of 2a, what? A and a, net voltage will be. Is it okay to call potential as voltage? Or let me confuse you more. Is it okay to call potential as, or is it okay to call potential voltage as potential difference? I have just rejumbled the words. You can think about it. In the meanwhile, what? V1 plus V2. V1 is K Q1, this, instead of Q1 minus Q upon distance A plus K Q2, which is plus Q upon distance till center is A, cancels out, 0. Electric potential for the final time is a scalar quantity, and you have to consider the sign of the charge whenever you do the numerical or any derive an equation. Alright, so moving on to find the value of electric potential at any point due to a dipole, minus q plus q. There is a very smart way to do this equation. What is that? Consider the distance from center of the dipole to be r. Let us say this is the point P where I have to find the value of potential. Okay, what are the distance from minus q to P? Consider it to be r1 and let this to be r2. Okay, simple. We'll start with a very simple equation, that is electric potential at P due to these two charges would be V1 plus V2, which is what? What is the value of V1 for this? K, this is K, then Q1 upon R1, right? Plus K Q2 upon R2. Take all these common things out. Q upon 4 pi epsilon goes out. You are left with what? Minus 1 upon R1 plus 1 upon R2. That means 1 upon R2 minus 1 upon R1. This gives you what? Net potential is Q upon 4 pi epsilon naught. How would you solve it? R1 minus R2 upon R1 into R2. You have already done this. Minus B upon D is, these terms are to be cross multiplied and denominators are to be multiplied within themselves. So A into D minus B into C upon CD. This was just for whom? Non-medical students? No, they are also good in maths. This was just in general info. So 1 upon 4 pi, Q upon 4 pi epsilon naught, R1 minus R2 upon R1 into R2. See, now I'll be using two suppositions which is actually valid in case of dipole. This diagram is actually like this. This is my dipole. Can you see this? And this is the distance at which I am finding the value of potential. So what will happen to this distance and this distance? Aren't they actually equal? Or at least they are at least equal to each other. So write down the statement, since dipole is very small, first R1 is approximately equal to R2 is approximately equal to R. So instead of R1 into R2, what you can write is R1 into R2 is R into R, which is R square. We have found a substitute for this term. I want something for this as well, R1 minus R2. What can you do in this diagram to find the value of R1 minus R2? Can we do something? What do we know about this diagram? That this distance was 2a. Okay. This is the central distance which is to be considered majorly. So considering this as a point and this distance R2, draw an arc which will be actually in a way perpendicular to all these three lines. So this distance from here to here, this is R2, this complete was R1, right? So this left part would be R1 minus R2. This is what we are interested in finding out. If this angle was theta, this angle is approximately equal to theta. We made an arc, that means this is a right angle. Use cos theta, base and hypotenuse. What is hypotenuse here? 2a. So cos theta is base R1 minus R2 upon 2a. That gives you what? R1 minus R2 is equal to 2a cos of theta. Use that value here. Second, cos of theta is R1 minus R2 upon 2a. That will give you R1 minus R2 is equal to 2a cos of theta. Put both these values here and get the answer. Electric potential due to dipole is Q upon 4 pi epsilon naught. This point 2a cos theta. Some of you must be thinking right now that Q into 2a is something which you already know. The dipole upon r square. So write the value of dipole P cos theta upon 4 pi epsilon naught r square, and this is the required expression we were finding out. My only question here is, okay, you know the formula of potential for a single charge. V is K Q upon R. Look at this point, K Q upon R. There is a charge, there is a distance. Here we have dipole moment and distance square. So in these two equations, the SI units of potential has to be equal. Are they or are they not? They are. How? P itself carries a charge and a distance. So one distance gets cancelled out from the square. So you are left with one charge and one distance apart from the K. Similarly, one charge and one distance and the K. So yes, they are equal. SI units are equal. What is the SI unit of potential? Joule per coulomb, right? If joule per coulomb is the SI unit of potential, what is volt then? They are all same. Electric volt, 1 volt is 1 joule per 1 coulomb. This is how we started our derivation, today's derivation, with this thing, that work done per unit charge is electric potential. So joule upon coulomb, volts. So define 1 volt. When you can use anything first. You can use 1 coulomb first, you can use 1 joule first. Do whatever as you like. When 1 coulomb of charge is moved so that work done is 1 joules, then the potential is said to be 1 volt. Or in other way around, when 1 joule of work is done in moving a charge of 1 coulomb, then potential is said to be 1 volts. Last point. What is the value of electric potential energy saved in rotating a dipole from theta 1 to theta 2? You have already done this. While doing the values of dipole in our last class of electric field, when this dipole minus q and plus q was rotated in the electric field from theta 1 to theta 2, what was the formula? Minus Pe cos of theta.